Welcome. My name is Eitan Suez, Technical Manager at Solo.io. In this lesson, we will look at the Gateway API from the point of view of what service mesh capabilities it enables and includes. So if you recall in the previous lesson, we studied different capabilities of HTTP routes, how we could apply different types of filters, and also how we could perform traffic splitting, which is very apropos for this lesson. We'll sort of recall what we did last time with I think it was the reviews service and splitting requests between two versions of that service. Now, that particular traffic split scenario was really designed for the gateway to handle. Any request that came through the gateway would get split in that respect. But the Gateway API also provides a way to control traffic in general inside the cluster, not tied to an ingress gateway per se. And that's what we call east-west traffic, and that's what we'll demonstrate in this lesson. And so we'll learn how to do that, how we can use the venerable HTTP route to control east-west traffic, not traffic at an ingress gateway. And for that, we'll need to bring into our cluster an implementation of the Gateway API that supports its service mesh profile, let's say, or that's conformant to those service mesh capabilities. Up until now, we've been focusing on kgateway, and here we'll bring Istio to help us with this task. And we'll basically test it. We'll put it to the test. We'll define some kind of traffic routing specification for the reviews service, but this time internally to the mesh, and we'll verify that it works correctly. And in the process, we'll also get a little bit acquainted with Istio in ambient mode, although that's more of a byproduct of the exercise. This is not meant to be a full treatment of Istio. So let us then come over to our sandbox lab environment, so to speak, and experiment with these capabilities. So we first take a look at what we did in the previous lesson, at least a route that defined two backend refs with weights. This is a traffic split scenario where 50% of the traffic was sent to reviews v1 and reviews v2. And the thing to point out here, a couple of things. One is that this sort of routing rule applied to requests coming in through the gateway to the particular path prefix /reviews. Now, with the Gateway API sort of service mesh initiative, what we see is the ability to sort of swap the parent ref. So in this case, we're looking at a parent ref that's the our infra gateway, and here when we look at this other route, we see that the parent ref is not a gateway at all. It's actually a service. So the way this works is, by definition, when the parent ref is a service, the way we interpret this route is to say that any requests that targets the review service will have this routing rule apply to it. And so that could be a request that comes in from the outside through a gateway, but it could also be an internal request from, say, the product page service to the review service that's internal to the cluster and never even goes through a gateway. So that's the idea. Now, how we're going to make this work is by sort of enlisting the help of Istio. And so the first thing I sort of walk you through here is running the Istio installation to install Istio in ambient mode. Now, we didn't have to do it in ambient mode, but this is sort of the latest versions of Istio. Ambient is already generally available, and so it sort of makes sense to. And the next thing we'll do as soon as the installation is done is to label the book info namespace. Here, let's just copy that and paste it in here so we can examine the command. There's a conventional label to say that namespace should be part of the mesh by saying the data plane mode is ambient. So all services inside the book info namespace are now part of the mesh, which means that Istio has the liberty to control how traffic is routed to them. Now, it does this with the help of a waypoint. A waypoint, you can think of it as an internal gateway or a proxy that's internal to the mesh, which Istio will control. And so we can deploy a waypoint in a manner similar, it's with the Istio CLI, but it's just as simple as when we provision gateways. It's slightly different. Here let's look at this command. We do a istio-ctl waypoint apply, and we specify the namespace book info to specify the sort of scope of the application of this waypoint will be responsible for intercepting or proxying requests that are targeted for services in that namespace. All right, so and as you might guess, this particular command has the side effect of actually provisioning a proxy. We'll see it here named as waypoint at the bottom of the listing inside that namespace. So we now have the kgateway proxy, which handles ingress, north-south traffic, and here we have this waypoint, which will be programmed by Istio, which will handle east-west traffic. So armed with that, there's one more thing I want to do, which is to deploy another sort of a helper pod, which we call a curl image. It's essentially, as its name implies, a curl image, which will act as a client from which we can make requests to the review service from inside the cluster rather than by doing a curl through the ingress gateway, although they both would be valid. But here I want to impress the point that we're actually controlling traffic routing inside the mesh. And now we can apply our sort of traffic split scenario, but not tied to the gateway, rather tied to the service itself. And so we can look at our HTTP route, and the thing I want to note here is in the status section whether the route was actually accepted, and here we see a condition saying the route was valid, so it indeed was accepted. And now we can sort of send in a test call. So let's study what this call exactly does. It basically makes a curl request from inside the curl pod running in the book info namespace to the review service, a particular endpoint on the review service, and it looks for the pod name to make sure that the request, to find out if which version of the review service is handling the request. Is it V1, V2, or V3? And if you recall from the route, I think it's 50%, should be 50% V1 or V2. So here we got a V1, and if we run this 10 times in a for loop, we should get a combination of V1 and V2 and no V3. So notice that this is internal requests. So for example, if product page were to call the review service, it would only get V1 and V2 at a 50-50 split, so to speak. So we can control traffic inside the mesh, and that's the point of this lesson. So let's go ahead and wrap up real quick and sort of talk about the main lessons from this activity. The fact that HTTP route is sort of polymorphic or has multiple talents. It can either be made to bind routes to a gateway or to a service, in which case it applies to internal traffic or east-west traffic. That Istio is an implementation of the Gateway API that supports the mesh features of the Gateway API. And that there are many other scenarios for service mesh which are not covered by Gateway API, or at least not yet. And so for those, we typically rely on the documentation and capabilities of whatever service mesh implementation we use. All right, so that's it for this lesson. In the next lesson, we're going to talk about yet another facet of Gateway API, and that's policy attachments. And so we'll see you in that lesson, and thank you.